Which of the following covalent bonds between hydrogen and non-metal would have the lowest overall magnitude in terms of potential energy based on the atomic radius of the atom? Okay, the lowest overall magnitude. Okay, so clearly remember the typical graph of the internuclear distance, that the lower the potential energy you get, the lower you have, the more stable. So we can just assume that this is like a 0. So if two atoms are really far apart, then there's hardly any potential energy between them. But when they have a perfect size, and the energy will be the lowest, and then when it is very close to each other, when it's really smashed near each other, then it will be very high in potential energy. So we want the lowest overall magnitude. So what does it mean? We want them to be as far apart as possible. Okay, so the magnitude, whether you have negative or positive, will be minimized. So what it means is that we need to find the longest distance. So we need to find the bond length from the given table and then look for the longest picometer. So starting with choice A, we have nitrogen with hydrogen. So another thing they are testing you here is how you can draw your molecule and determine whether it has double bond or single bond or triple bond. So if you draw your Lewis dot structure for ammonia, you get this structure, NH single bond. So NH 74, so between these bonds 74, hydrogen 37. So it's like you have nitrogen and hydrogen, and their internuclear distance is about 111 picometer. Now in case you don't know what pico is 10 to the power of negative 12. Okay, next thing we have a hydrogen fluoride. So we'll just add them up. 37 picometer plus 71. Yes, 71 picometer in choice B. That's smaller than choice A, so we can eliminate that. To minimize the magnitude of the potential energy, remember we want the bond length to be as large as possible. So choice C, we have CH4. C carbon has, okay, CH4, by the way, you have all single bond with the carbon. Choice B, in case you did not know how this works, with that structure, is a single bond between hydrogen and fluorine. So for carbon single and hydrogen, you get 37 plus 77. When you add this up, you get 114 picometer. So far this is larger or larger length. We can eliminate choice A. Because here we got 111. Okay, so the choice C so far is the largest. How about choice D? In choice D, we have H2O. Oxygen single 71 picometer, and for hydrogen we have 37. When you add this up, you get 108, and that's smaller. So you want to choose the largest, and that happens with the CH4 among the 4 choices we have.